This video is going to cover comparing probabilities of simple events. We've already talked about a few different types of probabilities, so let's summarize those. We have relative frequency and experimental probability, which is the number of times an event occurs over the total number of outcomes. It's based on actual results from doing multiple trials of an event. For example, a number cube is rolled 20 times, so there's 20 total outcomes in the experiment. For theoretical probability, this is the number of ways an event should occur out of the total number of possible outcomes. It is based on the outcomes in the sample space, not on actual results from trials. For example, a number cube is rolled. Since there's 6 sides to a cube, there's 6 total outcomes, theoretically. In our first couple of examples, here's the scenario we're looking at. It says a board game is played that contains a stack of cards. The stack of cards has 30 task cards, 15 expense cards, and 5 special cards. Alana randomly selects a card from the stack, records which card she got, and then returns the card to the stack. She repeats these steps 24 times. Her results are shown in the table. So in number 1, we're asked to find the relative frequency of selecting a task card. Whereas in number 2, we're finding the theoretical probability. So for relative frequency, we're considering that our experimental probability. And that's the information that's in our table. So I'm going to highlight that table in green because we're going to be using this information in the table to do our relative frequency or experimental probability. And I even on my own notes wrote next to that relative frequency. I actually put RF for relative frequency. You could also do experimental probability. That's a little bit longer to write. It's not as nice. But you can also do that as well. So we're going to use this information for our relative frequency or experimental probability. So as a reminder, we're finding the relative frequency of selecting a task card. Well, there are 14 task cards that we have, so we'll highlight this information out of 24 total. It actually tells us up here that she conducted this experiment 24 times. So our fraction is going to look like this. It is going to be 14 over 24. And we do want to write that fraction in simplest form and then as a percent. 14 24ths in simplest form is 7 twelfths. When we take 7 divided by 12 and move that decimal point to the right 2 places, we get 58.3 repeating percent. When we talk about our theoretical probability, that's what actually occurs or what we actually have. So we're looking at a real life situation. It's not based on trials or an experiment. And when we look at the original information up here where we're told we've got 30 task cards, 15 expense cards, and 5 special cards, that's going to be our theoretical probability. So we're going to be using that information for the theoretical probability. It is still the theoretical probability of selecting a task card. The one thing that we might want to do is total these numbers because our denominator isn't going to be 24 here. If we do 30 plus 15 plus 5, that's going to get us a total of 50. So I'm going to write that next to it. So my denominator is going to be 50 here. Now we had 30 task cards, so we're going to have 30 over 50, which simplifies to 3/5. And as a percent, that's going to be 60%. You might be able to hear my kiddos in the background. One of my kids just turned 10 today, so both of my kids are playing with the toys that he got and maybe being a little loud downstairs. So I apologize if you can hear them in the background. All right, let's take a look at our next example. It says, use the following information for problems 3 through 4. A number cube is rolled 30 times. The results are shown in the table. Find the relative frequency of rolling a 2. Remember, relative frequency is based on the experiment. So we're going to use this information that's given in the table, and I'm going to highlight that in green. I always like to kind of color code everything for us. So relative frequency is the information from the table. The total here is 30. They tell us that in the problem. We can also type down here that the total is 30 if we need to. If we're looking at the relative frequency of rolling a 2, the number 2 was rolled 3 times out of our 30 rolls. So we can write that as 3 out of 30. In simplest form, that is 1/10, which is going to be 10%. Now, when we go to find theoretical probability, this is based on real life. It's based on the fact that we've got a number cube with 6 sides. The probability of rolling a 2 is going to be 1 out of 6 because a 2 is one side out of the 6 sides that we have. So we have 1 2 out of 6 sides on that number cube. Now, 1/6 does not reduce, but as a percent, that will be 16.6 repeating percent. All right, moving ahead to the back of the page. It says expected probability is also known as theoretical probability. That's one of the reasons why I didn't abbreviate experimental probability as like EXP or EP, since we describe expected probability as theoretical probability as well. So, as we look at number 5, it says a coin is flipped 80 times and lands on tails 36 times. What is the difference between the expected probability percentage and the relative frequency percentage of getting tails? So let's begin with our relative frequency. So relative frequency is based on the trials, the experiment. So in this experiment, the coin was flipped 80 times and it landed on tails 36 of those times. So we can represent this as 36 over 80, which simplifies to 9/20. As a percent, that is going to be 45%. So again, for that relative frequency, we're using the experiment information. So for our theoretical probability or expected probability, we want to use the actual probability of the coin landing on tails. So each side has a 1 out of 2 chance of being landed on. So 1/2, of course, is 50%. So our expected probability is 50%. Now we want to find the difference between the expected probability percentage and relative frequency percentage. So we need to subtract those. So we're going to take 50% minus 45%, which of course is a difference of 5%. So it's pretty close. We really expected the coin to land on tails 40 out of 80 times, and it was pretty close to that at 45%. But again, we have that 5% difference. All right, so for our next question, similar kind of problem. We've got a spinner with 8 equal size sections numbered 1 through 8. It's spun 45 times and lands on a 7 9 times. What is the difference between the relative frequency percentage from the experiment and the expected probability percentage of getting a 7 on the spinner? So we're going to begin with that relative frequency, which is our experimental probability, and that is based on the experiment that we conducted here. So in this case, we spun the spinner 45 times and it landed on 7 9 times. So that relative frequency will be 9 out of 45. In simplest form, that will be 1/5, which is 20%. So in that experiment, the spinner landed on the number 7 20% of the time. So for real life probability or theoretical probability, also known as expected probability, the probability of the spinner landing on 7 is 1 out of 8 since there are 8 sections. 1/8 is already in simplest form as a percent. That will be 12.5 or 12.5%. So it actually occurred more than what we expected when we conducted that experiment. The difference between those probabilities will take 20% minus 12.5%. That will be a difference of 7.5%. Something to be aware of is the more times you conduct that experiment, so had we spun the spinner 100 or 300 times or 1,000 times, those probabilities would probably become a little closer together. The less times you spin it, the further apart they generally are. All right, let's go ahead and take a look at the next problem. Lamar has a movie collection at home, 12 comedies, 22 action, and 10 sci-fi. For 30 days in a row, he randomly selected a movie from his collection to watch. The results are shown in the table. Number 7, based on his results, what is the experimental probability, also known as relative frequency, that the movie he'll watch the next day will be a comedy? Write it as a fraction in simplest form. So we're looking at a comedy movie here, something for us to be familiar with, and we're talking about experimental probability. And the results of the experiment are in this table. A lot of times your experiment results will be in table form like this, so it gives you a little bit of a general guide there, also known as our relative frequency, of course. Now our total here is 30. They gave that indication also for 30 days in a row, so we could use that information. That's going to be our denominator. Our numerator is going to be the number 7, since we had 7 comedy movies out of 30. And that does not reduce at all. That is going to be a percent of 23.3 repeating percent. So again, the experimental probability of the next movie that he watches being a comedy is 7 out of 30, or around 23%. For theoretical probability, we want to use the amounts that are actually in his collection of movies. So theoretical probability of selecting a comedy movie, we're going to use this information up here. Again, this is our expected probability. The total of his movie collection is 44 movies if you total all of those together. 12 plus 22 plus 10. So that will be our denominator. Our numerator is going to be 12, since there are 12 comedies. So we are going to have 12 out of 44. That does reduce to 3/11. As an exact percentage, that will be 27.27 repeating percent. The 27 repeats. There's another question related to this. So it says that Lamar has a movie collection at home. We've got all this information again. We've got the information in the table to determine his movie that he randomly selected over 30 days. And the question we need to answer here is more of an analysis question. It says, which genre, which type of movie, was the relative frequency the same as the theoretical probability? Well, we know it's not comedy. So if we look at action, that would be 15 out of 30 for relative frequency, which is 1/2. And if I look up here and I look at action movies, if you remember the total was 44, 22 out of 44 is also equal to 1/2. I could check sci-fi. Those probabilities will not be the same. 8 out of 30 versus 10 out of 44. They're not exactly the same. So we could say that the genre that's the same is action, because both are 50%. 15 out of 30 for relative frequency, and 22 out of 44 for our theoretical probability. Not too difficult to find, but again, we could compare the 8/30ths to the 10/44ths. Those will not be the same. All right, so our next few questions ask us to kind of look at some graphs and figure out which graphs can represent different scenarios or experiments. So a tetrahedron is a 3D figure with 4 equally likely outcomes, 1 through 4, identified by the numbers showing at the top vertex, and you can see that here. Maribel tosses the tetrahedron, shown 50 times, while Dalton spins the spinner, shown 50 times. Each student records their results in a frequency bar graph. Neither Maribel nor Dalton wrote their name on their graph. Above each graph, write the name of the student whose graph best represents the results that can be expected from their experiment. Well, with this tetrahedron, each number is going to be equally likely, whereas when we look closely at this spinner, what do you notice? I hope you notice that sections 3 and 4 are larger. So what we know is that it's probably more likely to land on those sections than it is on 1 and 2. Now, does that mean that it will necessarily land on those more often? Not necessarily. But what we would expect is 3 and 4 to occur more often with the spinner than it does necessarily on the tetrahedron. We would expect kind of equal outcomes there. So when I look at our two graphs that we have, I would say that this frequency table or graph that we have would represent Dalton's experiment, which again was from spinning this spinner, because what we notice is that that spinner landed on 3 and 4 more often than 1 and 2. And this graph would represent Maribel's results, because as you notice on the second graph, the results are more evenly distributed across each possible outcome, which would happen with that tetrahedron. Dice usually are going to be fair when you roll them, flip them, whatever we might do. So think about this. With that tetrahedron, I can talk, each outcome is equally likely. But with the spinner, the outcomes for 3 and 4 should be more than the other outcomes. They should occur more often than the other outcomes. And that is because those sections are bigger. Those are larger sections. All right, let's take a look at another example with this. So Jaden and Nikhil each spin their respective spinners, shown 50 times. They each record their results in a frequency bar graph. Neither of them wrote their name on their graph. The story of a teacher. Names aren't on their papers. But above each graph, we're going to write the name of the student whose graph best represents the results that can be expected from their experiment. So let's look at the two spinners. What we notice about Jaden's spinner is that those sections aren't all equal. And in fact, sections 3, 4, 5, and 6 are bigger than 1 and 2. So we would expect 1 and 2 to occur less often than 3, 4, 5, or 6. Whereas Nikhil's spinner has all of those sections being equal in size. So we would expect each of those to occur about the same number of times. So think about which graph makes sense for which person. If you were thinking that Nikhil would be this bar graph and that Jaden would be this bar graph, you would be correct. All right, our last page. So two friends conduct experiments and record their results in frequency bar graphs. Caleb's experiment, we have a number cube with numbers 1 through 6 is rolled 70 times. In Joel's experiment, a card is randomly selected from a bag containing the following: 6 cards labeled 1, 2 cards labeled 2, 3 cards labeled 3, 5 cards labeled 4, 1 card labeled 5, and 4 cards labeled 6. And there are 70 trials. Same as Caleb's experiment. If we're rolling a number cube, we would expect each number to occur about the same number of times, which when we look at our graphs, that looks to be graph A. Let's see if graph B makes sense for Joel's experiment. So the ones that we would expect to occur the most often would probably be the number 1, because there are 6 cards with that. And as we look at that graph, 1 did occur the most number of times. We have 5 cards labeled 4, so that's probably going to occur quite a bit, and it sure did. And the other one is 4 cards labeled 6. We would expect that to occur a decent number of times as well. So I would definitely say that Caleb's experiment is going to be graph A, whereas Joel's experiment is going to be graph B. And I just noticed looking at these, Mr. Underkoffler made these notes, and those are the names of 2 of his kids. He has Caleb and Joel, so kind of funny to see that as well. Hopefully these notes weren't too bad for you. We will continue to review these things. We're going to reinforce all this probability, but you guys have been doing great with probability so far, so keep up that hard work, and thanks for listening.